This is a brief review of the procedure to do the virtual earthquake lab. You'll need to use the Firefox browser in order for this thing to work. It won't work in Chrome, and it'll probably work in Internet Explorer, but I'm not going to promise. So use Firefox. You'll probably get a message somewhere along the way asking if you are willing to allow pop-ups, and in this case you can say yes, allow pop-ups from sciencecourseware.org. It'll also ask you to enable or unblock Java, the Java programming coding plugin language at some point, and you will allow it to do that as well. The first thing to click to get started in this, once you arrive at the website that you can see here, is to ask for the travel time. And I will say don't block this particular application. I can say start. And the first thing is an informational window. The first thing to do is to create some locations for test stations, which will measure the actual travel time of a seismic wave from a created explosion to various sensing sites so that we can create a travel time graph to use later. So there's the explosion. Sorry if it was loud in your thing. I turned my volume way down. So that's the first step in this. I'll pause momentarily while I regroup. The next step is to look at the seismograms from this test explosion. And here's one at station 1. One can see the difference in time between when the P waves arrive and when the S waves arrive. It says the lag time is 31.1 seconds, and we can put that into the graph. I'm going to finish this while under pause. After having looked at all 5 stations and analyzed their seismograms, I have an SP lag time, difference between the arrival of the primary wave and the secondary wave for each of the stations. Next, I'm going to find the distance of each station from the explosion just by clicking on the station and dragging this thing, and it says here that my first station is 100 kilometers away. I'm going to pause and finish the table, and the table is now complete, and I can click on the button to verify the data, and it says everything is correct. Apparently it thinks that my data is consistent enough, and now it asks me to answer the last 2 questions, and they are what is the distance of a station from the epicenter if the lag time is 30.8 seconds. For that, I'm going to refer to a graph. Well, I think what I can do now is start to plot this graph, and then I'll use the graph. So this first point, the data that I found at a distance of 306 kilometers, the travel time is 31 seconds. And it's kind of hard to get my... Oh, it found my spot. I'm going to break now and finish the plot. After putting the points on the graph, I discover first, just as an aside, that I didn't spread out my distances very good, but I think I can still proceed with the exercise. What it's going to allow me to do now is to fit a line here, and it will tell me that I made a reasonable fit, so it's happy with my graph. So answer the 2 questions. Using this graph that I just created, I'm able to go ahead and answer these 2 questions, which I have to do before it'll let me move along. It says SP lag is 30.8 seconds. I just travel up to 30.8 seconds and find that my distance, if the lag time is 30.8 seconds, I happen to be 299 kilometers away from a seismic or explosive event. And now it wants me to look at 210, and that'll be 21.7, and I verify the answers, and I'm doing real good here. Got it right again. So I'm going to pause momentarily. At this point, it tells me to use the quit button, which sounds dangerous, but it's actually okay. It'll save the information that I just created, and away we go, and there's my travel time graph. And now I can click on the epicenter and magnitude exercise, which is the second half of this. And once again, it's going to ask me to enable Java. I'll start the activity. And now I'm going to begin the second half of this. I've already characterized how fast seismic waves move through the ground by creating an explosion and measuring. Now we'll go ahead and we don't, at this point, I do not know where the earthquake is. There's a variety of measuring stations. We quick trigger the oh, there was all pots and pans falling. We've triggered the earthquake, and the next step is to use 3 stations and measure the actual lag time between the P waves and the S waves by doing this. So I will measure, as I did before, at this station, station number 1, the lag time is 29.4 seconds, and I'm also able to and using that information, I will be able to estimate the distance from, using that data, as I interrupted myself, I will be able to measure or estimate the distance from the earthquake to this measurement site by how long it takes, the difference in how long it takes for P waves and S waves to arrive. And I'll do that by looking at the graph that I have. And if, according to my graph, if I am at 29.4 seconds, that suggests a distance of 286 kilometers. I will pause now and fill out more of the graph. I'm going to continue filling out this particular data table for stations 1, 3, and 7. And I'm going to in this case, for this column right here, amplitude, I'm going to measure how tall the S waves are. And I can control how tall my seismogram is in order to allow me to in order to allow me to measure the total height from the flat line right across here. So the total height is 44 millimeters, and that would be station 7. Continuing, I've measured the displacement or the amplitude or the height of the secondary shock waves here and filled those into the column. Next step would be to use this triangulation button here, 3 linked rings. Use this triangulation button to match each of the stations that I used, 1, 3, and 7, and create a ring around each of those that'll indicate at what distance away from that point the earthquake occurred. So for number 7, the ring is 199 kilometers. Since I know the travel time from the earthquake to this point is 199 kilometers, I've now located the earthquake on this circle. I can do the same with number 1, which is 286. And I know that the earthquake lies on both of these circles, so the earthquake was either over here or over here. And the third thing to find out, or way to add to find out, is to make a circle with station 3, which is 380 kilometers, and the intersection point is right there. And that intersection point is where the earthquake occurred. And I can go ahead and use my latitude and longitude button on the map to move the earthquake dot to that location, and I think I sort of made a mess of it here, so I better pause and fix it up. And what the computer's done for me is it's found the epicenter based upon the intersection of the circles. I didn't have to aim for the intersection of the circles, and it put a latitude-longitude grid on the map, and now I just have to read the longitude and latitude. So it's 115 degrees. The location of the earthquake is 115 degrees longitude, and throw in about 20 minutes more to the west, and the north latitude is 34 degrees and also I'm going to say 22 minutes because remember a degree is divided into 60 minutes, and it won't let me verify until I compute the use this little nomogram to compute the magnitudes. I have on this nomogram I drag this around or this around depending on the amplitude of the wave, and also depending upon the distance away. So I have an 18 wave amplitude. I have a distance of 286, and that says I have a magnitude of 5.2 for the earthquake, this particular random earthquake. I can also estimate my amplitude at 8.1, my distance away at 380, and I once again get an earthquake magnitude of 5.2 based on that station, and the final station is 199 kilometers away, and the magnitude is all the way up at 44, the amplitude, and it looks like 5.2 again. And finally I can verify my answers, and must have left something else out. Oh yes, it is. We are in the northern hemisphere and we are in the western hemisphere, and it thinks that my longitude measurement is not quite good enough. So back to the grid. It's 115 degrees and a little bit more, 115, and perhaps I need to tell it 22 and verify my answers. And it's going to be very misbehaving, but that's understandable because I'm rushing through this, and all I need to do is 15, 30, 45, 60. I rushed through this, and I probably poorly located my epicenter dot when I did this, and this is probably slightly off. So, embarrassing that it is, I'm going to end the lab there, assuming that you had much better luck and did this more carefully and weren't trying to talk at the same time you were doing it.